Hi guys, this is Objective 2.1. I can apply the angle addition postulate. Yeah, this lesson is really closely related to Objective 1.3, where we applied this segment addition postulate. So all the same ideas, except the only difference is we're talking about angles versus segments, okay? So let's do some important vocab quick. So as a reminder, an angle is when we've got one ray and another ray that connect at a common endpoint called the vertex. We can name an angle using notation where we draw a little angle symbol. And then we use the 3 points on the angle. I'll give this point A, point B, point C. So we could name this angle, angle A, B, C. Midpoint is a halfway point. Actually, we'll save a drawing for a second. Let's write the definition. Halfway point. Congruent is when we're talking about two figures that are the same size and shape. We can use a little squiggle over an equal sign to say congruent. That's the symbol for congruent. Congruency marks are a way we can show when figures are congruent. So if I have a segment here, and let's say that this is actually in the middle, that means this segment and that segment are congruent. Remember, we can use these ticks to show that. Adjacent is going to be helpful to negate. It means next to. And then an arc is just a curve. It's like the outside of a circle. All right? So we're going to first talk about angle bisectors. We'll skip over the let's figure it out section and jump right into the key points where an angle bisector is a line or ray that divides an angle in half and creates two congruent angles. So it's kind of like the midpoint of angles. So I'm going to show you how we could use a compass and a straight edge to construct an angle bisector. So let's say I want to cut this angle in half. All I have to do is place a compass at point A, at the vertex, and then draw an arc. I'm going to make my arc go through C and B. Okay? Then I place the compass at one of these points, one of these intersections on the side of the angle, and draw an arc that is then halfway past where like the middle of that angle measure would be. So I'm going to go about halfway, draw an arc. Whoop. Okay. Then place my point at B. Don't change the radius of the compass. Draw another arc. Okay. Point they intersect. And then here, that is my angle bisector. That's it. Okay, so again, notice that like I got this arc by opening my compass at a radius that was like half past the middle of that angle and drawing an arc. And then I drew an arc from this point too, and then just found that intersection. Okay, and so what I can do once I have this thing drawn, so like this is my angle bisector. This ray I just created here, that cuts the angle in half. Then I can use congruency marks now to label that this angle is cut in half. I can use congruency marks. So congruency marks, very similar to segment marks, but instead of being straight lines, they are curves because the measure of an angle is a curve. Okay, so these are congruency marks. You want to label when angles are the same with those congruency marks. Okay? And then, just to recap then, so if we've got something like OB bisecting angle AOC, so in this case, OB is bisecting angle AOC, then what that's going to mean is that angle AOB is congruent to angle BOC. So I can add those tick marks. I'm going to use two curves this time. Again, you can use any amount of curves you want. The same number of curves and arcs on both angles just means the angles are congruent. So the angles are congruent. So that means the measure of the angles, which we use an M and then the angle symbol to say measure of. That means the measure of these angles is going to be equal. Okay? So that's angle bisector. So kind of the midpoint of angles. Next, we're going to jump to the key points box on page 2 and talk about the angle addition postulate. So this is if angles are not necessarily the same. The angle addition postulate is very similar to the segment addition postulate, where basically it says if two adjacent angles share a side and a vertex. So I want you to notice here, there's two angles in this picture, right? Well, it's actually three, but MOP with that measure, right? And then we got angle PON with that measure, right? And they share this vertex O and side PO. And so there's actually a third angle here, MON, right, with that measure. And I want you to notice that the measure of angle MON is going to equal the measure of angle MOP, or POM, plus the measure of angle PON. Right? Like that, this big pink arc is equal to the yellow arc, MOP, plus the orange arc, which is PON, the measure of PON. Okay? So how that's going to help us is, let's say that this is, it's going to allow us to find angle measures if we're not using a protractor or like a construction to actually find angle measures. So if I look at this picture, for example, and I'm going to notice it says to write the angle addition postulate for the figure given. So what that means is TUV, so the measure of TUV, this big angle here, right, which is shown with that curve. Here, I'll do it again in color. It's shown, TUV is this big curve, right? That is going to be equal to the measure of angle TUB, which goes from here to here, TUB, plus the measure of angle BUV, which is right there. Okay? And so what this is going to allow, if we notice this, what this is going to allow us to do is, let's say we're given some measurement. So if we're given the measure of angle TUV is 170 degrees. So TUV, this pink arc, is worth 170 degrees. Notice I'm putting it inside the angle, not down here. That's outside of the angle. Okay. Then BUV is 150. Find TUB. I don't know what it is, so let's call it X. Well, what I can do is be like, okay, well, the measure of angle TUV is 170. That's going to equal whatever TUB is, X, plus BUV, 150. So now I have this equation set up where I can be like, oh, okay, well, if I have 170 equals X plus 150, let me subtract 150 and find that X is equal to 20 degrees. And that makes sense because 20 plus 150 gets us to that 170. So that's the angle addition postulate. Okay? Last thing I want to show you is on page 3. Now that we know those two things, bisecting and angle addition postulate, we are going to find variables and measures using algebraic equations. Okay? So, again, we're not going to use any more measuring tools to find angle measures. We're going to be given information about pictures and now use algebra, so variables and equations, to solve for stuff to find angle measures. So, example 3 says that if BX bisects ABC, so BX is bisecting this whole big angle ABC, and I notice I already see these congruency marks drawn for us, that these two angles are going to be the same measure. It says the measure of ABX is 5x. So I like to label my pictures. I think you should too. 5x. And then the measure of angle XBC is 3x plus 10. So XBC, 3x plus 10. It wants us to find x, the measure of ABX, and the measure of angle ABC. Well, if these two angles are the same, so if I'm noticing that ABX is congruent to XBC, that means their measures, which are 5x, is going to be equal to the measure of 3x plus 10. Whatever these two values are, degrees are, right, they're going to be the same. So I can set 5x equal to 3x plus 10 to say that these quantities need to be the same, and then find that value of x that makes both those quantities the same. Okay? So something to note here is that if angles are congruent to each other, and again, we knew that because we read bisects, that this ray was bisecting the angle, and then we have these congruency marks. Then you can set their expressions, so the 5x and the 3x plus 10, equal to each other. Okay? And maybe you remember this from when we did midpoint. All right, so now I'm just going to solve for x. So subtract x from both sides. You're going to get 2x equals 10. Divide by 2, divide by 2, get x equals 5. So that's me finding x. It wants ABX. So ABX is going to be 5 times 5, which is going to get me 25. So ABX is 25 degrees. And then ABC, how do I find ABC? Well, I'm going to use the angle addition postulate. I know ABX plus XBC is equal to ABC. ABX is 25. 3 times 5 plus 10 is also 25. That's me checking my work to make sure I actually got the same angle measures for both. So, cool. Equal to 25. And then, so that tells us 25 plus 25 gets us to ABC equaling 50 degrees. Okay, so using what we learned in the key points box on page 1 and on page 2 to kind of now use some algebra to solve for stuff. Okay? Next example says if OB bisects AOC, if the measure of angle AOC is 60, so let me draw that, 60 degrees, and AOB equals 4x plus 2, find x. All right, so what I'm allowed to do here is the minute I read bisect, I'm going to mark these two angles congruent. Actually, let me show you a different way to do congruency markings. You can also do one curve. You can do a curve and then like a little tick on the curve to make them look the same. All right, well, how do I do that? Well, there's two options here. If these two are the same, if this whole angle is 60, both of these angles would be 60 divided by 2, so 30 and 30. So to solve for x, I could say that 4x plus 2 equals 30. So subtract 2, and solve that equation. Get 4x, divide by 4, get x equals 7. I could also set up the equation that, okay, if these are the same, if this is 4x plus 2, then this is 4x plus 2. So that means 4x plus 2 plus that other 4x plus 2 has to equal that whole, that largest angle measure of 60. And that would give me 8x plus 4 equals 60. Subtract 4, get 56 equals 8x. Divide by 8, and get x equals 7. So two ways of arriving at the same answer, x equaling 7. The equation that's not true is 4x plus 2 equals 60. We're going to be tempted to do that. Don't do that because 4x plus 2 is only equal to half of that 60-degree angle. Okay? And so the takeaway here is kind of like if angles are congruent to each other, you could also use the same expression to represent both angles. That's what I did here to set up the equation equal to 60. Right? And that's it. Hope you enjoyed. Yay. Has to say hey. He's new from the zoo. All right. See ya.